Welcome learner, this is teacher Nicholas. Today we want to look at vectors, specifically vector 2. We know that it is a very examine part in mathematics and it normally carries 10 marks mostly. It is a very simple topic, one that you can understand easily, and I'm sure if you listen carefully and take note on some important things or concept, then at the end of the lesson I believe you will understand, or you will be able to get maximum marks on that. So before we look at the questions, first of all we need to remind ourselves some bits concerning vectors. So we know that vector from vector 1, vector is a quantity that has both direction and magnitude. So a vector is described by both direction and magnitude. So we can say that vector is a quantity with both direction and magnitude. Direction and magnitude. That's how we can define vector. So if, for example, we have vector AB, we can represent this with a line like that, whereby this is our A and this is B. So when it is like that, then it is not a vector, because it has magnitude. Magnitude is the size. For example, you can take this to be like 2 centimeters. So the magnitude here, magnitude which is the same as size, is 2 centimeters. But now we have to describe the direction, or to tell the direction for us to say that this is a vector. So the direction here means that you are moving from A to B. So we can denote this by or illustrate this by an arrow. So if you introduce an arrow there, which shows that you are moving from A to B, then we can say that this is a vector. So vector is normally represented or illustrated by a line with an arrow. So this is our vector AB. That is vector AB. And normally, if it is a printed form, then we indicate this by bold letters. But if it is handwriting, then we can have an arrow there, or we can denote it by a wavelength like that. So this is what can tell that this is a vector. So that is very important thing that we have to understand. So you need to know that a vector is not a point. A vector is a line with an arrow. And if, for example, you change the direction, for example, now we want to move from you want to write vector BA. You want to describe vector BA. It is the same line, the AB, the space is the same, that is 2 centimeters. So length or magnitude is still 2 centimeters, but now what is changing is the direction. You are moving from B to A, or maybe you can say your tail is B and the head is A. So here you are moving from B to A. So we can say that the direction has changed. So if you were to illustrate this with a diagram, then this is A and this is B, still it is 2 centimeters, then the direction will now change to be BA, to be pointing A, like that. So that the difference between this vector and the space or the length may be the same, but the direction is different, so that this vector is different from this. Also, we normally denote or represent vectors by small letters. For example, you can say vector AB is represented by A. like that. That means if our AB, if vector AB is given by A like that, then it means that vector BA will be negative A. This negative indicates direction. The direction has changed. You are no longer moving from A to B, but B to A. So this is very important. Maybe another thing that we have to learn before we look at some questions is the division of line. Division of line. Let us say, for example, we have line AB, line AB like that, and you want to divide this line into 4 points, equal points. Then we can say that this is point MNQ. The spaces are equal. We can represent these points or vectors between this point A and B. For example, we can say that AM will give it, we can give it as a fraction of AB. So AM will be 1 because it is 1 out of 1, 2, 3, 4, out of 4 AB. So we can give us a fraction. AM is equal to 1 all over 4 AB. So this one we can indicate by saying that AM is to MB is equal to, you have how many points between A and M? 1 point. That is 1 point. And then between M and B, ni how many? Or you can take spaces. This is 1. So 1 step. And then from M to B will be 1, 2, 3. So we can give us a ratio as 1:3. 1:3. So if you want to write this as a fraction, that is, you want to write AM in terms of AB, then it will be 1 out of 1 all over 4 total, which is 1 plus 3, which is 4 AB, like that. So it's good that you know how to write as a fraction and also a ratio. What about now if it is now n? So you can be told that n divides AB in the ratio. N divides AB in the ratio. How can we get that? N divides AB in the ratio. So what we need to do is that it is n that is dividing line AB. So we have to introduce n between AB such that we will be having AN is to NB. AN is to NB. And then now we count the number of points or spaces between A to and N. Like now AN will be 1, 2. So it will be 2:2. What about NB? NB is 1, 2. So this one is also 2:2. Whereby now, so this is 2:2. So another way, how can we write AN as a fraction of the whole line, which is AB? What we will do is that it will be 2. We know that there are 2 points between A and N. That is 2 all over the whole line is 2 plus 2, which is 4. So this is the fraction of, so you can say AN is equal to 2 over 4 AB, which now you can simplify to be, if you wanted to simplify, then it will be 1 all over 2 AB. So this is very important. This is called internal division of a line. And maybe AQ will be AQ is to QB will be, AQ is to QB will be 1, 2, 3. Will be 3 is to the whole line. QB will be Q to B will be 1, like that. So AQ is to QB. This one now we say Q divides line AB in the ratio 3:1. And if you were to write AQ as a fraction of AB, then it will be AQ will be 3 out of AB, will be 3 plus 1, 4 AB. So as a fraction, that is how we write it. It is important that you know this, because sometimes you may be given as a fraction and you require to write as a ratio, or you are given as a ratio and you will be supposed to write as what? As a fraction. So this is just an introduction. This is just a prerequisite of what we will encounter when we will be dealing with the question. So having learned this, I think now we are able to work out the questions. So we have this, our question 1. This is our first question. You are told in the figure below, M and N are points on OQ. M and N are points on OQ, and OQ and QP such that OM is to MQ is 2:3. So this one we've been indicated, meaning that the number of points between OM are 2, and then the number of points between MQ are 3. And you're told, and QN is to NP is equal to 2:1. So between Q and N we have 2 points, and then between N and P we have 1 point. So it is good that you indicate in your diagram, so that when you will be solving the questions, then you will not be having problems. You're told ON and PM intersect at X. This line here and this intersect at X. You're told, given that, our first question A, given that OP is equal to P. OP is equal to P. So we can indicate this by direction. OP, it is OP, which is equal to P. Can indicate that. And OQ is equal to Q, small letter Q. So also this vector here from O to Q is denoted by vector Q, like that. Express in terms of P and Q or N. Express in terms of P and Q. Express in terms of this vector and this vector O N, from O to N. So we're going to work out together that one. So we want to write vector ON. Here, what we need to understand is we need to know the direction. You are moving from O to N. You are moving from point O to N. So this is our starting point, and our last point, which will be our destination, will be N. So ON, and we want to write, to give in terms of vector P and vector Q. So what we do, we know that ON, one route that you can follow to move from ON, because now if you go directly, then there will be you will not be having P and Q to use. So if you want to move from O to N, you can either move from O to P and then P to N. You can move from O to P and then eventually P to N. At the end of the day, you will have started your journey from home, which is O to N, like that. Or you can move from O to Q, then Q to N. So whichever the case, you can use this and then this, or you can move this way and then the other way, like that. So ON, we can decide to use ON as OP plus PN. OP, then PN, like that. It is very important that you understand that direction matter in vectors. Without direction, then it will be if you don't understand the direction, then it will be very, very hard for you to get the marks here. And direction very easy, because what you need to know is where you are starting and where you are going. Your starting point and the end point. So ON, in terms of P and Q, then OP is, we have been told that OP is P. Then we can just write OP is P, plus Pn. You can see that Pn is a fraction of PQ. Pn is a fraction of PQ. So what fraction? It is 1 unit over total. Total will be 1 plus 2. So it is 1 all over 1 plus 2. Do you still remember how we did it in our introduction? It is 1 out of the whole, which is 1 plus 2. 1 over 3 of PQ, of the whole line, which is PQ. So that means we need first of all to look for PQ. We need to look for PQ in terms of P and Q. So PQ, you are starting from P to Q. So for us to use P and Q, then we can decide to go from P to O, and then O to Q. P to O, then O to Q. We know that. So PQ will be equal to PO plus OQ. PO plus OQ. Why are we doing this? It's because we want to look at to find this vector, this PQ in terms of P and Q. So PO, you can see the magnitude is the same, but the direction is different, because we know that OP is P, positive P. Then PO, when you are moving this against the arrow, then it will be the sign will change, because the sign here is positive, then the sign will be negative P. Plus OQ is just the same, the direction is the same, and we know that OQ is Q, so it will remain to be positive like that. So that now our ON now will be P plus a third of PQ, which is negative P, plus Q. This is this, and I have to introduce a third. So this one now, if you open the bracket, will be P plus minus positive times negative will be negative a third P, then positive will be positive a third Q, like that. So these are like terms, and this is the same as 3 all over 3P minus a third P. That will give us what? 2 all over 3P plus 1 all over 3Q. So this is our first answer for vector ON. That is, and there are 2 marks. Then the other one is Roman 2, whereby we are looking PM, vector PM. We want to move from P to M using P, vector P and Q. So PM. So that is our direction, PM. So PM, one way that we can go, you want to start from P to M. You can have to follow this route, PO and then OM, or another person will go through this route, PQ, then QM. Both will give you the answer. So it depends on you, the one that you like. Mostly you take the shortest route, the one that can give you the answer faster. So PM, so my decision is, or my way could be PO, this is O, PO plus OM, PO plus OM, PO then OM, PO plus OM. PO, what is PO? PO, we know OP is positive P, then PO will be negative P. I believe you understand that. Plus OM. OM is, you can see, it's a fraction of the whole line, OQ, or the whole vector, OQ. What fraction? OM. Between O and M, it is 2 all over total, which is 2 plus 3. 5 of what? OQ. Vector OQ. You have to show that these are vectors. Okay, so this will be negative P plus 2 all over 5 OQ. What is our OQ? We are told that OQ is Q, small letter Q, like that. So that is the answer for that, because you have given in terms of P and Q. So you just write in terms of P and Q, but you have to simplify the way we could have simplified this, but you can see this is direct. And still, if you do that, then you will get your 2 marks. So you just have to, what you need to understand here is very simple, just the direction. How will I reach this point from this? I can move from that point to that, and then that to that. That is what you just follow. It's about the route and the direction. So I believe you have understood how we do that. Then the other part of the question is this, whereby you are told, given that OX is given by H or N, and PX is given by KPM. We have to indicate that in our diagram so that we are able to work it easily. OX is H or N. OX is H or N. H or N. Then PX is KPM. Where H and K are scalars. So these are scalars. Scalars are quantities with magnitude only, without direction. So we are told, by expressing OX in two ways, determine the values of H and K. That is 5 marks. By expressing OX, so you want to move from O to X in 2 ways. We know that we have so many routes that we can follow to move from O to X. So how do we solve that? How do we do that? So we want to write OX in 2 ways. Vector OX in 2 ways. We want to start from O to X. For you to be able to get, because later you'll be told you are told, by expressing OX in 2 ways, determine the values of H and K. So for us to be able to solve that question, what we need to do is that we have to write OX in 2 ways. One must involve H, and then the other one must involve K. The scalars that later we will look there. We will find their values. So one way is that we go directly. OX is a fraction of ON. That is, OX is H or N. That's one way. H or N. Another way is that OX, because I told you that we have to use this H and Q. So we have found one way whereby we will be using scalar H. Now we want to find another route that will enable us to use K. So there are so many ways that you can use. It can be OQ, then QP, then P plus PX. Or you can go OP plus PX. I told you that you choose the one that will give you the answer easily. So we can say that OX, one way that we can get through K is OP. Then we will have to move from OP, then plus OP, then PX. OP, then PX. So we know that OP is P plus OP is P. PX, we are told that it is KPM. We have to use this KPM. KPM. So you can see that this is another route. This is the second route that we can use in order to reach X from O using H and K. You can see in the first route we have H, scalar H, and in the second route we have scalar K. So it is important whether you are told to express OX in 2 ways. What you need to understand, so long as you are supposed to look for the values of H and K, or the values of the scalars, then what you need to do is that you can look for a point which is at the middle there, and you can express it in 2 ways. One to use one scalar, and then the other one to use the other scalar. but now we have to write this in terms of vectors p, and q. So root 1, the first one, ox, which is equal to h or n. So in terms of p and q, then ox will be equal to h or n. But the good thing about vectors is that you find that what you'll be using here, you have already found in the first part of the question, so you don't have to toil to look for it again. So what we will do is that we just use what we got before. So we know that on is p plus a third this one here. We know that on is equal to 2 over 3p plus 1 over 3q. So we just have to introduce it here. So it will be 2 all over 3p plus 1 all over 3q. When ox is h or n, already we found on to be 2 over 3p plus 1 over 3q. So we just have to multiply to open our brackets. So it will be 2 all over 3hp plus 1 all over 3hq. So this is one root. This is I've just written our first root in terms of p and q. The second one now, the second root will be, I can write it here, ox, which is equal to op. This is the second root now, op, which is p, plus kpm, but I know we found pm, vector pm is negative p plus 2 all over 3/5. So we don't have to work it, to look it, or to calculate or to find it again. We are just going to use what we found here. So it is negative p plus 2 all over 5q. And if you open the brackets, then it will be p minus kp plus 2 all over 5kq. This one now we can simplify this, because we can see that we have two terms of p, vector p, so we can write as one term. So what is common is p. If you factor out, you will get p 1 minus k, like that. You can put it this side or that side, it means the same. So by writing this way, now I have written it as one term, plus 2 all over 5kq. So that is it. So I believe what I've done here, I've just simplified this. That is to write as what? As one term, because you can see that they are like terms. So yeah, they are unlike terms, but both are terms of p. So we can write them as one term by introducing bracket. But this one is just one term. So we leave it the way it is. So having written it that way, for us to get the values of h and k, then we know that we are moving the same place, ox. So this ox is the same as this ox. The first ox is the same as the second ox. So that means the terms of p, the terms of p in this. So what we need to do is that for us to get the values of h and k, then because we are saying that we are moving, this is just the same thing. So the values of p, vector p in the first root is the same as the values of vector p in the second root. The values of vector q, or this term here, the q term in the first root is the same as the second, the terms in the second root. So we just equate using the two roots, equate the terms of vector p. That's what we can do. The first thing, you equate the terms of p. So in our first root, what are the terms of p? The first root here, this is our first root. The terms of p are 2 all over 3 hp. So we can just write the way it is, 2 all over 3 hp. 2 over 3 HP. It is the same as the terms of P in this case, in the second root. This is our second root, which is, so this is equal to P into 1 minus K. What I've done, I've just equated the terms of P in the first root and the second root, because we are OX is the same as OX in this case. So we can P will cancel with this P, so that will be 2 all over 3H is equal to 1 minus K. We can write one scalar in terms of another one, so we can decide to multiply this side by 3 all over 2. We multiply also this side by 3 all over 2. This will go with this will go with this. We remain with H, which will be 3 all over 2 minus 3 all over 2K. So this is like our equation 1. So we have found the value of H in terms of K. Then the second way, or the second step will be equate the terms of Q, vector Q, and the two roots. Equate the terms of vector Q. So what is our Q in the first case? In the first root, our Q is this. This is our Q. That is a third HQ is equal to, in our second part, in our second root, what is our Q? Our Q is 2 all over 3 KQ. 2 all over 5, not 3. 2 all over 5 KQ. So you can see that Q in here is the same as Q in this second root. Why? Because of OX here, and we also have OX here, the same thing. So what we do, just as we did in the first case, we have to cancel Q with this. Q will go with Q, and then we will have a third H, which is equal to 2 all over 5 K. But we found H in terms of K in the first case. So what we do, instead of writing H, we are using substitution method. We'll write this on its behalf. So we'll write 1 all over 3 into 3 all over 2 minus 3 all over 2 K, like that, is equal to 2 all over 5 K. Why am I doing this? I want to make the variable to be 1 so that I get the exact value, or its actual value. So if I simplify this, it will be a third times 2 all over 3 minus a third times 3 all over 2K is equal to 2 all over 5K. So no, it is a third all over 3 all over 2. Sorry. Yeah, a third times 3 all over 2. If you open the bracket, minus a third times 3 all over 2K. So this will go with this. I will left with a half minus this will go with this, a half K, which is equal to 2 all over 5K. So if I collect like terms, I can take K to the other side. It will be a half is equal to 2 all over 5K plus 1 all over 2K. So a half is equal to, the like terms here, like terms is 10, not like terms but LCM is 10, which will go 2 times 2, 4K, plus this will go 5 times 1, 5K. So it will be a half, which is equal to 9K all over 10. Then now I want to remain with K in one side. I will multiply by reciprocal, that is 10 over 9. I multiply by 10 over 9, so that I'm left with K in 1 with one coefficient. So K will be equal to, by this 5. So it will be 5 over 9. So that is the value of K. So we have found K to be, the actual value of K is 5 over 9. Then the other one, now we want to get the value of H. The value of H now will be 3 all over 2 minus 3 all over 2 into bracket K, which is 5 over 9, because our K is 5 over 9. So this will be 3 all over 2 minus, if you simplify this by this 3, so it will be minus 5 over 6 LCM will be 6. This will go 3 times. 3 times 3, 9 minus 5, which will give us 4 all over 6, which is the same as 2 all over 3 if you simplify. So again, we have found our value of h, the actual value of h, which is 2 all over 3. So that is how we normally look for the scalars. You write one vector in two ways. One must involve h and another root must involve k. After that, now because it's the same vector, then you equate the values of the terms of p, so that you get one variable in terms of another one, and then you equate also the terms of another vector, which is q. Then now you substitute from the first equation, and that will give you the exact value of one scalar. And then after that, you use the substitution or the first equation to substitute, so that you get the value of the second scalars. So the values of our scalars are k is 5 over 9 and h is 2 all over 3. So that is how we do that. So then the other question is that determine the ratio in which x divides pm. Determine the ratio in which x divides pm, the ratio. So what we are looking here, or what we are supposed to do here, is that we want to write, we are told determine the ratio in which x divides pm. So because it is x that is dividing pm, so what the ratio that we want there is px is to xm. You remember in introduction, px is to xm. So what is px? Px we have been given as a fraction. Px is, we know that px is kpm. Px is kpm, and we found the value of k to be 5 over 9. So it is 5 over 9 of what? Of pm is to xm. Xm now will be so you can see that if you were to write this as a fraction, so this will be px will be equal to 5 over 9 pm, meaning that from p to n, from p to x you have 5 points, but the whole line, which is pm, is 9 points. So px is to xm now will be px, which is 5, and then the remaining now for you to get 9 over 9 will be 4. So you'll say 5 and then 9 over 9 minus 5 over 9, which is 4. So from this point to this you have 5, and then from x to m you have 4, so that all of them will give you what? 9, because that is the fraction of px to the whole line is 5 over 9, meaning that the total number of points are 9, or is 9. The total number of total points is 9, and the points from p to x, the points are 5, so the remaining ones will be 4. So the ratio at which x divides pm will be 5 is to 4. So I believe you have understood what we have done there. So that part is very simple, because you can see that you have been given the fraction of px to the whole line, which is pm. So the fraction is 5 over 9. So if this is 5 over 9, then from x to m will be 4 over 9. So to write as a fraction, so it is 5 over 9 is to 4 over 9. So if you were to simplify this, you just multiply by 9, you multiply by 9. So you will be left with 5 is to 4. Thank you. So I believe you have understood. We are able to work out our first question successfully. So now we will be doing another question.